Hello people, welcome back to my channel. So in the previous video we saw different types of methods for classifier evaluation. That is, we had the holdout method. Then there were some limitations in holdout method, so that's why we moved on to random sampling, and it has also got some limitations. So we today have the topic of cross validation. So before this we understood the concept of hyperparameter and why it is used. So some of the concepts of hyperparameter will also be used in today's video regarding the cross validation. So I suggest you, if you haven't seen that video, just check it out before watching this. So let's begin. So why we require cross validation? So we already did the random sampling approach. So it has one problem of the overlapping test set, and there were no control of how about the training and test data was used. So this essentially solves that problem. So in this you can see the data set. So in this what I have did is I have 9 instances and I have split into 3 folds. So this mainly is divided into 3 folds, and so this cross validation is also called as k-fold cross validation. So the main purpose of cross validation, or why it is used in machine learning, is that it reduces the variation in the results caused due to the sampling of the data. Mainly in random sampling we did the data distribution in a random way, so because of that we had certain issues. So in order to overcome that we use the random sampling, and mainly k-fold cross validation optimally selects the hyperparameter in this approach. So in this what I did is I have data set. So I have k instances, that is I have 9 instances in this, and so what cross validation suggests is that one subset should be reserved for test. Means one of the subset or one record will be used as a test set, and the rest, that is k minus 1, will be used as training set. So with this approach, that is a set of equal sized partitions. So you need to divide into equal sized partition, that is k equal size partition. Means if I divide it into 3 segments, then each of the segments should contain 3 records. So this very first record that you can see, that I've considered as a test set, and rest 2 I've considered as training set. In the next iteration what I have is, I considered this part as the test set and the first and the last part as training set, whereas in the last iteration, that is I have kept the last part as test set and the first and second as training set. So in this you can see the test set never get overlapped, and each of the segment gets participated in at least one test set. So that is the main motto of this. So there should be at least one record that should be used as test set, and the remaining can be used for training set. Now the rest of the approach remains simple. So with this with the training data, you just run on the model, and the performance is evaluated on the test set, and you get some accuracy. Say for this you have some accuracy of 1 as 0.9, and with this, say for example you have the accuracy of 2 as 0.7, and with this you have the accuracy 3 as 0.6. After this it is averaged over the formula, that is ACC is equal to 1 upon k summation I runs from 1 to k. You have ACC of I. So you get the average of this, that is E1 plus E2 plus E3. Similarly how we did in random subsampling, and you get some estimate. So this is how the approach is there. Now the main thing is that you need to tune the hyperparameters. So k-fold cross validation mainly selects the hyperparameter. So with this approach you get some hyperparameter. Now you need to tune it. So for tuning, what you basically do is you do a grid search. Now what it basically has is, it will take all the hyperparameters as input, and it will do the combination, and then it generates the model which has the highest accuracy. So it considers a map. So here on the x-axis it has the number of nodes. Say for if you are evaluating for a decision tree, then you have the number of nodes, and on the y-axis you have the minimum instances in leaves. And so you have different nodes, say 300, 500, 1000, and for each of this you have say 200 instances, you have 300 instances, you have 500 instances, and accordingly it calculates the error. And say for example these are just samples which I consider, and you get different parameters. Let this be 0.65, 0.7, 0.9 and 1.2, and out of this what basically does is it just calculates the minimum, that is the lowest error rate, and it considers that particular hyperparameter and it goes for tuning. So this is how the technique of cross validation basically works. Now there is one disadvantage, is that you select the test set in a fashion where it is like first this set will come, then in the next iteration this will be the test set and this will be test set. So in this approach what you have, the generalization error or the error estimate recorded is usually very in a poor manner. So and one more thing is you need to just combine the k-fold cross validation and also the grid search in a separate way. So there should be some method or there should be some estimate where you can just club these two approaches. So that's where we go for nested cross validation. So it has both the advantages of tuning the hyperparameter as well as estimating the generalization error. So that we'll see in the next video. And before that there is one concept, say like if you have this k, that is a parameter here, that is for the k fold, if I consider k is equal to n, so this becomes one variation of cross validation that is called as the LOOXV, that is leave one out cross validation. So here you have exactly one test record and you have that is n-1, whichever is remaining as the training. So what this basically has, it covers the entire data set. Now there is one disadvantage, is that you can guess, that is n, that n is the data set size. So if you have, so here I have considered just 9 examples. If you have 10k examples, some way you will manage this, but if you have 100k or even 500k or even 1 million test instances, then this approach would take considerable amount of time. So that is one major disadvantage of this approach. And so we want to club the generalization error estimate and also the hyperparameter tuning. So that we'll do in the nested cross validation. So well, that was all regarding the cross validation approach in machine learning. So hope you guys enjoyed this video. Actually watching this video, please do like, share, comment, and if you are new to the channel, please consider subscribing. Thank you very much for watching this video.